All right, so I want to look at just one more way to look at the climate and weather data. And so this will just be by monthly sums of both the GDDs and the precipitation, right? So in this case, I'm going to go back up to the pivot table. I'm going to group selection, get rid of the days, right? So I have month and year as sums. And I'm going to look at the, I should also put precipitation in here. Drop precipitation there, and value field settings, summarize value field by sums. And then I'm just going to go down here, and let's say we're going to look at 17, 18, and 19. Just copy them, right? Bring them over here. This is where I did the LTAs by month. And just paste these in here. So this is GDD, this is Precip. So I've split these. The LTAs for the GDDs is in here, and for precipitation here. So now I'm just going to go ahead and start moving these over. So 2019 is going to go right there. (2018) and 2017. There you go. 2019. Okay, and now I'm going to do the same thing for precipitation. All right, so now we've got this all there. So we've got LTA, GDDs, not cumulative, just monthly sums for all these years. So again, we don't need January and February. We can get rid of that. And we don't need November, December for GDDs. We do need to look at that for rainfall. We need to look at the whole year for rainfall. The growing degree days only matters for the growing season. Right, so highlight your whole data set, go to insert, go to recommended charts, and there you go. Just go ahead and use this clustered column chart. Again, don't forget to define the axes. All right, so this is GDD base 50F. There you go. So, right, it's a little bit difficult to look at, but what we can see 2019 is that, again, we can see that warm spring. We had a cooler than average July. So that perhaps, so this is for Raison in here. So maybe Raison started a little early. Perhaps was a bit slow. We'd have to look at weather right around Raison, but it may have cooled down. But then it warmed up again in August. We had a warmer than average August and a cooler than average September. Also, you'll see in the precipitation data, kind of a wet fall, which was problematic. And then a very cool October. But most of the fruit comes in the door in September. Okay, so that's how to interpret that data. As you can see, like if we look at some other stuff like 2017, cool start to the season, but then a very hot season overall, right? So when you're interpreting this kind of data, like for your papers and stuff, I want you to do that. Like, don't just make these graphs and present the graph. Talk about the figure, reference the figure, right? So say things like, okay, 2017 was a cool spring, so probably a delayed bud break, but then like a cool April. But then in May, June, July, August, September, it's much warmer than the long-term average. So phenology was probably advanced. And what this also means is that the wines were probably a bit bigger coming from 2017, right? They're probably a bit more phenolic. Maybe more alcohol. Maybe less acid in 2017, unless people made judicious acid adjustments in the cellar, right? These are the kinds of things I want you to discuss. Okay, so now let's go ahead and look at the precipitation data. So I'm going to do it also as a column. It's fine, whatever style of chart you want to do is fine. All right, so again, one thing to discuss is just mean annual rainfall, or how much rain has fallen within each season. That's one thing I would show in like a table or something in your discussion of weather and climate for your area. So like if we look at 2017 here, it looks like 2017 was a pretty wet year for the Willamette Valley, right? And it was in the winter months. In the growing season, it was a wet spring. That was actually a hard spring. It was hard to get stuff into the vineyard. It was so wet. But then the majority of the growing season was actually not very wet. It was pretty average through the growing season. But outside of the growing season, that winter was very wet, which was good because the groundwater had been recharged, like the soil was at field capacity going into springtime. So we had quite a lot of water in our deep clay loam soils with high organic matter in the Willamette Valley through the growing season. So our vines really didn't want for anything in terms of water, even though we were in that hot season with high evapotranspirative demand. If we look at, let's look at 2019. In 2019, the one thing you can see here is this extreme rainfall in September. Very high rainfall in September. Why is that problematic? Well, when is harvest? September, right? So we had rain before a lot of the fruit came in the door in the Willamette Valley, and a lot of the fruit turned to mush. So this is one thing you could discuss in a paper and say high rainfall post-veraison probably led to higher incidence of disease and botrytis, which may have led to wines with greater volatile acidity, less tannin, less color. Yeah. Okay, so that's kind of what I want you guys to do for these graphs and for these papers. Don't just, like I said, don't just make the graphs, interpret the graphs. What do these mean? How does the rainfall and the heat line up with phenology? What is it? So what does it mean for grape and wine quality? Okay, cool. Hope all that helps.